Hello from the Forcetronics YouTube channel, and welcome to part 3 of building your own AVR or Arduino Internet of Things board. This is part 3 in a 5-part series. If you haven't seen the other 2 parts, I'd recommend you check them out before watching this. And in part 3, we're going to look at our final design. We're going to look at our schematic and the parts list for our final design before we go to PCB layout. Let's get started. So let me first start off with a correction. So as I mentioned, I'm doing this in real time. So I'm doing this project as I create these video tutorials. I made a mistake on one of my parts, and that is the DC power jack. So the one I bought off of Newark, and I provided a link to the part number on my blog. I bought it with the power pin, that center pin right here, too large. The one on the Arduino board is actually 2.1 millimeters, and I bought one that was about 2.5 millimeters. So I've corrected that and bought the right one. You can see the part number, or the part name I should say, and the link to the data sheet for Newark. Once again, I'm sorry if you already ordered that, but like I mentioned, there might be mistakes as we go along, and here's one of them. I ordered the wrong power jack. Now we have the right one. Here it is. Okay, with that correction made, let's look at the final schematic. And what you're actually looking at is the schematic view on Eagle software for PCB layout. So I'll use this later for the PCB layout, but right now I'm just using it as the picture for my full schematic. And I'm not going to go over all the parts because we touched on most of them in the part 1 and part 2, but I will talk about the pins and the other things that I've added to the design. So if we move from left to right, you can see I have this is the DC power jack, so this is where our input power is going to come, and this is the LM317. That's what you're seeing here. Now note that on the Eagle schematic, whenever you see an arrow like this or the ground connection like this, that anywhere you see these, there's a common connection. So for instance, here's VCC here, and then here it is down here. So these are both connected to the same spot. Okay, so here's our input power. This should look very familiar. This is the potentiometer, the adjustable potentiometer. One thing that's different though is these 2 pins here. And these are actually going to be 2 0.1-inch pin headers that I use as a jumper, or I should say as a way to disconnect the input power from the power of the electronics on the board. Basically, there'll be a jumper across here. So if I wanted to just isolate this from the design and have some other type of power source. Let's say if I wanted to be able to test the low power capabilities, I wanted to eliminate the LED and I wanted to eliminate the regulator, I could do that by disconnecting this jumper that I'll have here. So you'll see I'll use this a couple places. And once again, the whole point of this design, or one of the points of this development board, is to be flexible, to have flexibility, and this is one of those examples. So if we go down here, this is going to be the Arduino power pin row. So if you think of the Arduino Uno board where you have ground and you have V-in and you have 5 volts and 3.3 volts and reset, that's these pins right here. Now one thing I should note, and I might have mentioned this in an earlier video, I don't know, I can't guarantee that this board is going to be compatible with any Arduino shields you might have. And the reason is I'm not going to have a 5-volt source here. This is going to be a 3.3 volt board. You can see that I just tied the 2 pins. So one of these pins, this one right here, is typically 5 volts. I just tied them both together so they're both 3.3 volts. So just keep that in mind for this design. Okay, if we go up here, this is the actual Arduino chip, or the Atmega 328P. Here's the inductor that I added. This is going to be optional, but this is there to reduce noise to the ADC, because this is the ADC reference input. Up here we have the input pins for the programmer, the FTDI cable or board. Okay, over here is another example of flexibility. So I put jumpers here. These are going to be male 0.1-inch pins that I can attach a jumper. So if I wanted to, and these are actually these are the serial communication pins for the BLE that connect it to the Arduino Uno. I can actually, isolate it from these connections if I wanted to. If I wanted to have serial communication somewhere else, I could do that. I also did that for the reset pin on the BLE micro board or module. So the BLE micro board essentially serves as a wireless serial connection over Bluetooth or Bluetooth Low Energy. So you don't need a lot of these pins. But what I wanted to do, in case you want to hack this chip and change the firmware on it, I'm going to give the board access to some of these pins, actually most of them. But some of them I leave blank, and that's just essentially because I don't want to fill up the board with a bunch of these pinholes that we probably won't use. So I won't have actual pins here, but there'll be pinholes on the board in case you want to put pins there to access or hack this BLE micro module. But some of these I won't connect at all. So that's just something to note. And then finally, another example of our flexibility, and I know this is going to be hard to see here, but I'll talk about the parts later. I'm going to put a small solderless breadboard on this development board, and that speaks to the flexibility of this board. So this is what these pins here represent. So these are going to be pins that you could put a sensor on or some type of transducer, and on two of the pins I'll have ground and VCC. But once again, you won't have to solder on here. You could just put it on there, and that's the whole idea, is to make this board flexible for Internet of Things type ideas, so on and so forth. So that is the schematic. Okay, here I am showing you the example part for the jumpers. So I talked about how part of the flexibility is I'm going to be able to isolate the power or also parts of the BLE module from the Arduino or from the rest of the board. And I'm going to do that with these 0.1-inch male pins. You should be very familiar with these if you're a maker. But these are the jumpers I'm going to use. So you just connect these across here like I'm showing here, and that shorts them together. And then you can remove them to isolate that connection from the rest of the circuit or from whatever they're connected to. I bought these from AliExpress. They were real cheap. I got a very large bag for maybe a couple dollars. Here's the female header, the 2x4 female header. Once again, 0.1-inch spacing for the pins that I'm going to use for my mini solderless breadboard. So what I'm going to do is I'm going to put two of these next to each other, and I'll be able to use them like a solderless breadboard because they're the same spacing as a solderless breadboard. So I'll put two of these next to each other, and as I mentioned in the schematic, I basically I didn't mention in the schematic, but what I do is I short these together just like a breadboard, so two of them will be shorted together, and on two of the connections I'll have ground and VCC. Here's an example of the inductor I used. So I actually grabbed this. I don't have a good part number to share. I grabbed this from a bin at a local electronic part provider near where I live. So I don't really have a part number for it. Here's the dimension. It looks almost like a resistor, but it's an inductor, and this is what I'm going to use to reduce the noise to the ADC. Once again, this is an optional part. I provided an example link on AliExpress, but this link will not take you to this exact same part, but a similar part that'll fit on the PCB board that we design later, just like this fits. Okay, here's my parts list, what I'll call the final parts list. We talked about a lot of these parts. I'm not going to talk about them again, but the whole idea is this just provides a final parts list. So if you want to look at it and know what you need for the board, here it is. All right, for our next part, we're going to dig into the PCB board. So we're going to build the PCB board, and what I'm going to use is I'm going to use Eagle PCB Design Software. There's a link here on the screen for Eagle. Eagle is free for hobbyists. So when you go to download it, there's going to be a pay-for version, but you can get a free version for hobbyists. I would recommend that you get a basic understanding of Eagle. So I'm going to go into part 4 assuming that you have a basic understanding of Eagle. I'm not going to do a full tutorial on Eagle, but what I will provide though at the end is my Eagle files. So if you don't want to do the layout yourself, you just have to know how to lay out the files and get what's called the Gerber files to send to a PCB board manufacturer, and I'll talk about that in part 4. If you're new to Eagle and you want to start learning it, there's a lot of tutorials out there. There's some on the Eagle website. SparkFun has some, as well as a fellow YouTuber, Jeremy Bloom. So check those tutorials out if you want to get started with Eagle. All right, that's it for part 3. In part 3, we looked at the final design, the final schematic. We looked at the final parts. We made our board really flexible for prototyping. And next, we're going to do the PCB layout. So if you haven't already, subscribe to my YouTube channel. If you want the parts list, go to my blog And if you have any questions, feel free to email me. Thank you for watching.